Good morning. This is Dinesh from Knowledge Institute of Technology, Salem, Tamil Nadu. Today I am going to present a topic on energy meter. Here I am going to explain about the electromagnetic induction type single phase energy meter, construction and working, torque equation as well as error adjustments of the same type of energy meter, also a block diagram of the digital energy meter, or we can say electronic single phase energy meter, and I'll complete my session with a three phase energy meter. First of all, we will see that what is meant by energy meter. Energy meter is a device. It is going to measure the power with respect to the time. So that is, it will give a total amount of consumption for the particular period. For example, it may be for a month, or it may be for a year, or it may be for a day. In particular day, how many units it has consumed, we have consumed, or in a particular week or in a particular month, how much units we have consumed. It is everywhere available in the home. Nowadays we are having both analog as well as digital meters. So here we are seeing the construction of the electromagnetic induction type single phase energy meter. Here, as we are seeing, there are three types of magnets are provided. So what are all those magnets? We will see here the construction part. So the first and very important part is the driving mechanisms, how the particular disk is going to rotate. So it is based upon this driving mechanism magnets. It is having a two electromagnets. One is the series connected magnet and another one is the shunt connected magnet. Here you can see that series connected magnet is nothing but a current coil, and the shunt connected magnet is nothing but a pressure coil. So this is the red line and this one is the blue line, that is nothing but current coil, and the red line is nothing but a pressure coil. It is made up of silicon steel laminations which from a rigid mechanism structure. On series magnet, U-shaped current coil is mounted, and for a shunt M-type electromagnet is mounted. It is the magnetic here pressure coil is highly inductive in nature. Copper shunt bands are provided on shunt magnet so that phase displacement of 90° between flux set up in by shunt and series magnet. We can provide a copper shading band, the main of which is what? We have to create the phase difference. Current coil is connected in series with the load. And again a moving system, here moving system again shown in the green, and it's nothing but how the disc is going to rotate. So here the rotating aluminum disc is mounted in the spindle. Bottom of spindle is pivoted in the bearing screw. See here, pivoted screw. Top of the spindle is connected to the recording mechanisms which will give the gear trains. So we can easily see the analog meters. The reaction between the flux produced by eddy currents due to shunt and series magnet. The shunt and series magnets reactions will make the disc to rotate. To overcome the friction loss, light load adjustment is provided on the spindle. We have provided this one, light load arrangements for reducing the friction losses. So next we will discuss about the braking system. Here braking system is provided by the C-type magnet, C-shaped magnet. Here braking magnet is so placed that the disc revolves in the air gap. So this is nothing but the air gap between the C-type magnet. This magnet field induces eddy current in the disc, which reacts with the main magnetic field and creates braking effect. By changing the position, see here, by keeping the magnet inside or keeping the magnet outside, we can control the braking effect. The braking disc can be adjusted. Registering mechanism is nothing but it will provide the how much units it's consumed in a particular year or a particular month. Here see that the different dials are provided. The second dial is from the right from the 10 kilowatt hour Then third is the 100 kilowatt hour. This is the 100 kilowatt hour. And the fourth is the 1000 kilowatt hour consumption. Sometimes 1 by 100 and 1 by 10th kilowatt hour also we are providing for the accurate result. The train gears driven by pinions or worm gear. So next we will discuss about the operations. So here how the flux in the shunt and series magnet going to provide a product of this effect, and your disc is going to rotate together, because everyone knows the power formula is VA cos phi. So here we can see that the flux produced by pressure coil phi SH is the flux in the pressure coil, and phi SE is nothing but the flux in the current coil, this one. Okay, and the flux phi SH induces EMF ESH in the aluminum disc. The same disc, due to this flux there will be a EMF induced here, and same way due to the flux in the series there is a induced EMF in the disc. So the disc is short circuited, so there will be a two eddy currents because of the shunt and series flux. So one flux here, see that flux direction in between the series coil, the one flux is going upward and the second flux is going in the downwards in the series magnet. The interaction between phi SH and IES produce the torque T1, and the interaction between the phi SE and IESH produce the torque T2. So this way the resultant torque will give the rotation in the disc. So these are all the further detailed explanation of the energy meter operation. Finally, the net developed torque can be getting from this formula K3 into VI cos phi. It's the AC power formula. The braking torque developed on the disc is proportional to its speed. So if the speed is increasing, the torque, the braking effect also will get increases. TB equal to K4 into N, and N is nothing but the speed of the disc. The meter constant K can be calculated as K equal to total number of revolutions upon energy in the kilowatt hour. There are different errors in the energy meter. One is the speed error. Sometimes your energy meter, analog, especially in analog energy meter, people are complaining your disc is rotating more faster, so the bill may be higher, or sometimes disc won't rotate accurately, so that bill may go lesser. So these are the main cause because of the brake magnets. This can be reduced by arranging the or adjusting the brake magnets. Then we have some of other errors. Meter phase errors are there. Then friction errors. So amount of weight, how much we are going to add in this, based upon that we can have. Then creep. Creep is the another type of error, and due to the variation in the temperature, that time also we have the error. So these are all the, and some more light load and friction adjustments. These are all some other types of errors. So creep can be avoided by providing the hole on the disc. So these are all the main constructions and working and errors in the energy meter. And this is the type of energy meter as for used in the three phase. So here we have a three arrangements of a single phase energy meter will make a three phase energy meter, and this the circuit shows the three phase